we are going to review for today. It is conversion, scientific notation, and order of magnitude. Okay. Now, these topics, you will not see them maybe on their own usually on some exams. They are usually a part of another topic in which you might be given something and then you're asked to convert your answer in standard form, or should I say scientific notation. Now, a lot of the time in physics, we are going to be required to convert stuff. For example, you might be given a mass in grams. You should be able to convert it to kilograms because we work in our SI units. You might be given a distance in centimeters. Then you're going to be required to convert it to meters, which is our SI unit. So let us look at some things now in regards to scientific notation, conversion, and order of magnitude. The first thing that we're going to look at is scientific notation, a very, very simple topic. Now, for scientific notation, we usually represent numbers in this form. It's like A, which just represents a number, but there's a particular range for this number. I'll let you know after. So it's going to be A times 10 to the B, A times 10 to the power of B. Or some people might say to the power of n, whichever way, it doesn't matter. So A times 10 to the power of B. The thing that we must remember though is that A is going to be a number that ranges from 1 to 9.9999 and so on. So therefore, A should be less than 10, but it should not be lower than 1. Okay, so those are the range of values for A. And then B now is just the power of 10. So let us look at how we can convert these numbers that we are given into this form. The first thing that we need to know is that in order for us to create the value of A for this first number, I need to move a decimal point from where it's currently located to this location right here. Okay, so now I'm going to create the value for A, which is 4.314 times 10. Now, how do I get the power? I want to see how many decimal places I moved. I move 1, 2, 3, 4, 4 decimal places. Whenever we are going to convert a number that's greater than 1, or let's say any number that's greater than 10 or so forth, to scientific notation, our power should always be positive. Let's look at number 2 now, in which our power is going to be negative. We are converting a number now that's less than 1 to scientific notation. So therefore, we want to move our decimal point to this location to create 3.3941 times 10. We move the decimal basically 1 place. So therefore, this is going to be to the power of negative 1. So we have converted this number now to scientific notation. Let's look at the number 99. We want to move it from here to here to create 9.9 times 10 to the power of 1. We only move it 1 place. Let's look at this one now, 5. Now the decimal point is where we want it to be. So therefore, I'll just write back 5 times 10. How many places did I move it? It's 0. Didn't move at all. Good. We all should know that 0, 10, any 10 to the power of 0 is the same thing as 1. So this is the same thing as saying 5 times 1, which is 5. So you realize the identity of a number remains the same. So therefore, we have converted these now to scientific notation. It's a very, very simple concept. The first thing that we need to remember for scientific notation is that we want to create a value that represents the A times 10. Then we are going to have a power. Okay, the thing that we must remember is that A must range from 1 to 9.99999. So that means less than 10. And then times 10. And B is just going to be your power. Okay, and we just looked at how to basically work out how to get the power. All right, so that's all that we need to know for scientific notation. Please let me know if you need me to go through more examples for scientific notation, but I think it's a very simple concept. All you need to do, write down these examples and try them repeatedly. Now let us look at the next topic, which is conversion, a very, very important topic for mathematics It's also it's just a life, it's an important topic for life. Because for example, let's say you travel from one location to another, it is important that you're able to convert. I know that we now have those smartphones where we can just type it in. $1 is basically how much dollar in South Korea. We can work that out immediately. But it would be good if we know the process to get those answers. Okay, so this is what we are going to look at now. So let's look at these 5 conversions, and how I'm going to go about doing it is by using conversion factors. So we are going to use conversion factors, which mean the first thing that I need to know is a relationship between the two units. So I need to know the relationship between grams and kilograms, centimeters and meters, coulombs and elementary charge, joules and electron volts. Once I know the relationship between them, then I can now create a fraction, then I can do my working from there, okay? So for example, the first one, let's just look at the first one. We know that there is 1,000 grams basically in 1 kilogram. Okay, so we know that there's 1,000 grams in a kilogram. Now from this, I can create two fraction. I can create a fraction of 1,000 grams divided by 1 kilogram. And because 1,000 gram is basically a kilogram, this is basically like I'm multiplying by 1. So that simply means anytime you multiply by 1, the identity of the number remain the same. So now, because 1,000 gram is the same thing as a kilogram, that's one conversion factor. Or we might be required to use this one, 1 kilograms over 1,000 grams. Now, which of these should I use? It is very, very simple. The one that I need to convert from, I need it to be in the denominator of the fraction. So therefore, I'm converting from grams. So I need the grams, so I have to use this one. So therefore, what I'm going to have now is 890 grams multiplied by 1 kilogram over 1,000 grams. Okay? Now, any number by itself will have a denominator of 1. So therefore, what we're going to have now is 890 grams kilograms divided by 1,000 kilograms. These units will cancel each other, and then all we are left with is just grams. Once we do this division, we should get 0.890 kilograms. Grams. This should be grams. Okay? And that's the answer for the first one. Very, very simple. Let's look at a next one now. Let us quickly look at the next one. Now, the second one, we are trying to convert 48.3 kilograms to grams. Very simple as well. So now we are moving from kilograms to grams. So immediately I know I'm going to use the relationship to create a fraction, and I need the kilograms in the denominator. So the conversion factor that I'm going to be using is going to be 1,000 grams divided by 1 kilograms. 1 kilogram. Now we know that there's 1,000 grams in a kilogram, so that's the conversion factor I have to use. So therefore, I'm going to have 48.3 kilograms multiplied by 1,000 grams divided by 1 kilogram. Remember, any number by itself should have a denominator of 1. So therefore, now we can just cross multiply. Or let us say we can multiply numerator by numerator, denominator by denominator, and we should get 48,300 gram divided by 1 kilogram. The kilogram will cancel the kilogram, so all we are left with is 48,300 grams. And that's our final answer. Very, very simple. So whenever we have conversions to do in physics, they are very, very simple. Once I know the relationship between the two units, then I can basically go ahead and get my conversion going. Let's look at the next one. If I have 97 centimeters to convert to meters, this is our next very simple conversion for us. The first thing that we need to know in order to get this done, we must know that there's 100 centimeters in 1 meter. This is something that we must know. Then we are converting. The second step now, we are converting from centimeters to meter. The one that I'm converting from must be in the denominator of the fraction that I'm going to create. So I'm going to put 97 centimeters. I want to convert it to meters. So therefore I need 100 centimeters in the denominator. Then in my numerator, I'm going to put 1 meter. Any number by itself will have a denominator of 1. So let us look now. If we multiply numerator by numerator, we're going to get 97 centimeter meter. Then right here, we are going to get 100 centimeter. Centimeter will cancel centimeter. Then we can just divide the numbers to get 0.97 meters. So we have converted 97 centimeters to meter. So please, I hope that you're realizing that this is very, 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 very simple. I can't stress how simple this is. The thing is, you need to practice. So you need to write down these examples on a blank sheet of paper. Practice it, look back at the video, then try to do it again. Let's look at the next one now. We have 17.2 coulombs to convert to elemental charge. Now, we might not know what is a coulomb as yet, or we might not know what is a elemental charge. But even if we don't know, once we know the relationship between them, we can do the conversion. Now, how do I get the relationship between them? The first video that I made, I talked about the reference table. That is where we're going to go to find the relationship between elementary charge and coulomb. Let us look. Now, if we go to the page that contain all the constants, we should look until we see coulomb and elementary charge. This is one relationship. One elementary charge is equal to this amount of coulomb, or the second relationship, 1 coulomb is equal to this amount of elementary charges. Let us go. I'm going to use a first example. No problem. Let us use the first example. 1 elementary charge is equal to 1.6 times 10 to the negative 19 coulomb. So it's a 1e, 1 elementary charge is equal to 1.6 times 10 to the negative 19 coulombs. So therefore, the first thing that I need to look at is, okay, I'm converting from coulomb. So I'm going to create a fraction now. I'm going to have 1e divided by 1.6 times 10 to the negative 19 coulombs. Then I'm going to use that fraction now to multiply the one that I'm trying to convert from. So I'm trying to get 17.2 coulomb to elementary charge. That is by itself, so therefore the denominator is definitely 1. Okay? Now we'll multiply numerator by numerator, and what I'm going to get is 17.2, if I put elementary charge coulomb, divided by 1.6 times 10 to the negative 19 coulomb. Coulomb will cancel coulomb. Then the rest of it now is just basically the work of your calculator to divide 17.2 by 1.6 times 10 to the 19, and you should get your answer in elementary charges. So it's a simple concept, very, very simple concept. Okay, so for this one, you can punch it in the calculator, you should get your answer. Now let us look at the last one, then we're going to move on to the final topic for today that we're going to look at. Next one, to convert from joules to electron volts. Now again, we go to our reference packet. Our reference packet is showing us that there's, in terms of electron volt, 1 electron volt is really equivalent to 1.6 times 10 to the negative 19 joules. So 1 electron volt is equivalent to 1.6 times 10 to the negative 19 joules. 1 electron volt is equal to 1.6 times 10 to the negative 19 joules. There we go again. We are converting from joules. So I need joules in the denominator. So if I say 84 joules times, I know the denominator must contain joules. So I'm going to have 1.6 times 10 to the negative 19 joules. Then I'm going to have 1 electron volt in my numerator. Multiply numerator by numerator. I'm going to have 84 joules electron volt divided by 1.6 times 10 to the negative 19 joules. Joules will cancel joules here. And all I need to do now is to divide the numbers, and I will get my answer with just 1 unit remaining, which is electron volts, which is what I am trying to get. Very, very simple concept. Very, very simple concept. Look at these examples. Try them again and again. Another way that you can do it is just to create examples of your own. Let's say you create an example. Let's say we want to find out 4,000 electron volts is equivalent to how much joules. You can go ahead and try it and then utilize the internet now. Type that inside the internet. The internet will tell you the correct answer. You do your work in and you match it to the answer that you're given. Okay? So now let us look at the final thing.